Quiz day.
Yeah, finally.
All right.
My AA took this quiz like last Monday or something.
Yeah. You're right, actually.
I almost forgot y'all hadn't taken it yet. Seriously.
What's the next unit we're doing?
Limits?
Limits. Are those, how would you, those pretty hard, easy?
Each day is not too bad, but last year the quiz, it was the lowest quiz average of the semester. It wasn't a low average, but it was the lowest of everything else.
Gotcha.
It's one you have to stay on top of for
For sure.
Romero,
Sure, yeah, problem solved.
Allen, Brody,
Everybody on Life Live are active.
No.
Yes, your mind's
Okay, Jaden, Brody, Romero. Romero's late. Brody's late. Alright, before we start our quiz today, I need to give you one last chance to get some points from this unit. I know it was just a 3-day, today was day 4, 3-day unit, but if there was anything you did not turn in on time, but you went back and completed, you can still get late credit for it, but I need it before we start the assessment. And if you forgot to turn in the review, which was number 63 in the Google Classroom, I can take your hard copy before we get started as well. But you need to double check that because this would be just like last semester. I won't take assignments from this unit once we test it. So. You will also need a calculator. You're allowed a calculator and you need a calculator. And before I bring you your quiz, you'll need to put your phones and smartwatches up. So do that, clear off your desk, please. Yeah, I do. Sorry. Rated, you're number 9, so I think that's along the back somewhere.
So is this for a test credit or quiz credit?
It's a 30-point major assignment.
Oh, it's major.
But it's 30 points. Right now, it's your only major grade, so it'll be 60% of your grade temporarily. Again, you need to get your phones and stuff put up as well. And once it looks like your desk is cleared off, I can let you start. As promised, we will provide the formulas for you. And then in the top half of the page, have the formulas. Thanks. Did I skip anybody that I did not come back to? Okay, so once again, 30 points total, which at the end of the semester is not gonna be that big of a major assessment. But right now, it's gonna be your only major grade in the grade book. So temporarily, once I grade this and put it in the grade book, it will be 60% of your grade. So, of course, you wanna double check your work as much as possible. I'll point out that like on questions 2, 3, 4, all the questions you need to read the directions, but if you look at those for just a second, we give you a couple points for the right answer, and then a couple points for the formula with the numbers plugged in. So the only reason I'm verbalizing that is even if you feel comfortable enough to go straight to your calculator, type it in your calculator, hit enter and get the answer, that's still only going to be half the points. You still need to show us the formula with the numbers plugged in. So as long as you're writing down what you put in the calculator, it should be fine. And then the last piece of advice I would give you is just make sure that you're using the formulas correctly. Every year there's a student or two who will use one of the formulas, but they forget a letter, a variable, they forget a 2, they forget something, and it will be counted wrong. Just because we're providing the formulas, you need to make sure you're using them correctly. Okay.
Do you have a calculator?
I do. Just hand it back to me when
Thank
you're done. Okay. And I can't give you the full class period on this, but I can give you most of the time. You do not need to feel like you're rushed it off. But once you're done, you can come turn it in as usual. Pick up your phone, wait quietly, and once they're all in, we're going to look at those 2 pieces of paper you picked up so that we can start thinking about the next unit. course, you should also double check that your answers seem reasonable. If two sides are 5 and 10, and you solve for the third side and you get 400, there's a good chance something's wrong with that.
warranty. Mhm.
I have a question. This one, can I put an S instead of this so I don't have to write out the whole thing?
Yeah, just like draw an arrow to it or something. Okay, that'd be fine.
Thank you.
Again, as you guys finish, just pick up your phones and wait quietly, please. Some people will want to take a bit more time. both, and you have to have the work to show. That's the extra if you chose to learn it.
Is it angle side?
I can't say more than that.
Okay.
I can tell you at the end of class if you want to know. It was optional to learn it. I told you there'd be a bonus on it.
Alright. So, this in, but I didn't. It's okay if you still grade it.
Yeah. Just double check next time.
Yeah, I was trying to, but my phone wasn't loading.
Okay, I got it. Thank you.
Thank you.
got all the quizzes in, so if you're working on something for another class, go ahead and find a stopping place here. We need to look at the other all right, so I do have 3 students from my 8A classes that missed when they took it, and you guys know during advisory we have had no movement for cap and stuff, so hopefully they come and take it on Tuesday, and like last semester, if you'd like to come see your quiz, you are more than welcome to. But if you remember when we started that, really all of that was for you and for the ACT. The ACT about every other time throws a law of sines or a law of cosines question on there. Just because you did not have to memorize the formulas for us, you should probably want to at least be familiar with those. That would be a good thing to review if you knew you were taking the ACT the next day. But we are going to move on to our next unit, which is limits. And this is the same stuff that we do the first 2 weeks of AP Calculus AB, except in Calculus, sorry. So in calculus, we spend about 4 days and then test this on the 5th day. And so we like to do this in pre-cal for a couple of reasons. One, it shows you a little bit of real calculus. Everything else we've done is pre-calculus, stuff that like helps you in calculus, but it's not really calculus learning. 2, for those of you that are doing calculus next year, it makes the first couple weeks a little bit less stressful. Especially coming back from summer break and stuff when you're not really in school routine and stuff. But we split this up into very, very manageable chunks. The, I guess, biggest challenge in this unit is you just kind of have to make sure you're keeping up with it and not let it keep up with it and not fall behind on your end. So there's a couple quick little things I need you to add. So these 2 pages that you picked up on your way in, both of these make up 65. And each of these questions honestly take about 5 seconds to work once you see what to do. But we're going to have to talk through it for a few minutes. So the first thing I need you to be aware of is the most common misconception is that students mix this up with a point. A limit is not the same thing as a point. When we talk about a point, what we're saying is when x is this number, y is that number. So mathematics already has that covered. Limits don't do the same thing. What limits do is a limit question would look like this. It would say LIM for limit. It's going to tell you the number that x approaches. So as x gets close to this number of some function, it gets closer, or it approaches this y value. So a point means when x is 3, y is at 4. A limit means, at least this one, as x gets closer to 3, y gets closer to 4. That doesn't necessarily mean there's a point at 3, 4. It's just a way to describe the y value that it's approaching. Okay, and the other thing you should write down, even though this doesn't come up on this assignment, in a couple class periods, this is a B week, so I will see you guys again tomorrow, and you guys will be caught up with 8A then. But there is a couple different types of limits. There's this one. If there's a little negative sign here, this means from the left. From the left. So if I was asking you, what is the limit as x approaches 3 from the left, you would take a number slightly smaller than 3, and you would inch your way towards 3, and you think about what y value it gets closer to, the closer x gets to 3. And from the left side, that appears to be -4. Now notice, it doesn't even exist there. There's a hole there. But that's okay. Limits don't really care what's happening at 3. It cares what it's approaching as x gets close to 3. So from the left side, the y value gets closer and closer to -4. And then sometimes you'll be asked, there could be like a little plus looking exponent thing. This means from the right side. So the limit as x approaches 3 from the right, you would need to take a number slightly bigger than 3, move back towards the left, get closer to x equals 3, and the closer x gets to 3 from the right side, the closer the y value gets to -4. And if you approach the same number on the left and the right, if it doesn't designate whether it's from the right or the left, that implies that it needs to come from both. If it approaches -4 on the left and -4 on the right, the answer to that question is -4. Again, you don't need to write this out with each question, but this is what needs to go through your head. You got to think about what y value is it getting closer to as x gets closer to this. What y value does it get closer to as x gets closer to that? If these are the same, that's your answer. And if they're different, we say the limit does not exist. So again, I'm going to really emphasize this because this is the part in about a week students start to not understand. You got to make sure that, again, we're not going for quantity here. I'm not asking you to do 50 of these questions, even though you realistically could. We're going for quality here. I don't care that this point does not exist. Limits, and a lot of times with limits, teachers will even say like, you can just completely ignore what's happening at x equals 3. It does not matter. It has no impact on the limit. It's not a point. Okay, so now I'm not going to write all that out, but we're going to say it verbally. The limit as x approaches 0. So 0 from the left looks like it gets closer to a y value of 2. As you approach x equals 0 from the right, the y value gets closer to 2. And if it's approaching 2 on the left and it's approaching 2 on the right, then the limit is 2. That's it. You're just thinking about what y value does it get closer to. Once again, notice it doesn't even exist at y equals 2. That's okay. It's way down here. It has nothing to do with the limit question. It's kind of a distractor to see if you think that the answer should be -7. All right, what would be a reasonable estimate for the limit as x approaches 5? So from the left, looks like the y value gets closer to -2. Approaching from the right, it appears to be approaching a y value of -2. And if it approaches -2 from the left and the right, -2 is your limit answer. So it's not a hard concept, it's just a little bit different than what you've had to do in the past. A little different notation. Yeah.
Can there be limits for finding y?
For finding 5,
Or finding y. So like,
so you're told what the limit is and you have to find the x value?
yeah.
The very last question on our worksheet will be like that. Okay, so again, I'm basically just going to be saying the same things here because that's all that really matters. The limit as x approaches -1, I need to think about what y value does it approach from the left. What y value does it get closer to from the right? And if it approaches the same number from the left and the right, that is your limit. You're just describing the y value that it gets close to. I don't care what's happening at x equals -1. I don't care if it's a filled-in circle, an open circle, a point somewhere else. I don't care what's happening at -1. I care what's happening near -1. Yeah.
Good question. Wait, is there ever going to be a time, you know how the arrow's going this way and the arrow's going this way? What if they're different? I mean, is that even possible?
It is possible.
Okay.
So it depends on the question. If it specifically said, and again, this doesn't come up today, but if it says from the left, whatever y value is approaching from the left would be your answer. If it says from the right, whatever y value is approaching from the right would be your answer. But if it doesn't say and it needs to be both, then we're going to say the limit doesn't exist. They have to be the same from the left and the right.
So would this happen only like, let's say,
It's about to happen about 5 times on the next page, so you're seeing. Did you have something? Okay, and one other way, I want to talk about one more together, and I'm going to have you try the next 3 as guided practice. But same idea, but in a table. And honestly, this is kind of what can be difficult about calculus sometimes, is you learn a skill like what we just talked about. We talked about it on a graph, but can you translate that to a table without practicing it 50 times? And can you translate that to a function without practicing it 50 times, etc.? But it's still the same idea. I want to know what I think the y value is approaching as x approaches -2. So from the left, I would take a number smaller than -2 and get closer to -2. It looks like the y value is getting closer to 8. It's just an estimate, I don't really know. From the right, I would take a number slightly bigger than -2 and move closer to -2. And the y values appear to be approaching 8. So I'm testing the same thing, the information is just provided in a different way. If it approaches 8 on the left, 8 on the right, then the limit must be 8. It's got to approach the same number on the left and the right. Okay, I would like you to try 6, 7, and 8 in just a moment, or for a moment, because again, each of these questions should be pretty quick, but commit yourself to an answer. We'll go over them, check, make sure you don't need to add something to your notes. And then we can do the 3, or is there 3? Yeah, the last 3 on the back page together too. But I want you to try at least a couple on your own. Okay, I'm going to cut you off. Even if that wasn't enough time, at least let you see where you slowed down. Okay, so number 6, the table. What's the limit as x approaches 1 of f of x? So it looks like from the left side of 1, it approaches probably -6. That's a good guess. The right side of 1, as x gets closer to 1 from the right side, it appears to be approaching a y value of -6. If you approach the same thing on the left and the right, then that is your limit. So, I said this one a few times, but this didn't come up in any of the other questions, but I wanted to give you a chance to think about it. If this question had said, what's the limit as x approaches 4 from the left? You would take a number slightly less than 4, move closer to 4, and say that your answer is 3. If the question had said, what's the limit as x approaches 4 from the right, you would take a number, an x value slightly bigger than 4, and then move backwards towards 4, and see that its y value gets closer and closer to 6. Again, notice, I do not care what's happening at x equals 4. That has nothing to do with the question. You can totally ignore if there's a point, where there's a point. That doesn't matter. So that could be the answer if you come from the left. That could be the answer if you come from the right. But if it doesn't designate, it has to be both. And it can't approach two different numbers. So in this one, we would say that this limit does not exist. Or you can just abbreviate D&E. D&E is a known math acronym. So again, limits are just trying to describe the y value that it's approaching. So we can't have half the people saying 3 and half the people saying 6. It's got to come to the same number on both sides. Now, unfortunately, I didn't scramble these questions up the best. I forgot to change that last year. So we're going to see the same thing for a few questions in a row. But as x approaches 0 from the left, it appears to be 5. At x approaches 0 from the right, it appears to be approaching -5. And if it's approaching a different number on the left and the right, then this limit does not exist. Has to be the same on the left and the right. Finally, on the last page, as x approaches -4, from the left, it appears to be getting close to a y value of -3. From the right, it appears to be approaching 2. But if it's not approaching the same thing, the limit doesn't exist. You don't need to put any more thought into it than that. If you have a graph, that's all you need to be checking for. Okay, and again, I apologize, these are not scrambled up the best, but as x approaches -5, looks like it's approaching 6. From the right, it's approaching -4. Either way, it's approaching different numbers. That limit does not exist. And for one kind of twist, just to try to make you think of the question backwards, the last question I want you to try, this time I'm telling you what I want it to equal, and I'm asking you to look through there and see if you can find an x value that would have that limit. There's more than one answer, but see if you can find at least one x value it could approach to have a limit of 3. Okay, so I think there's actually 3 possible answers here. Here's where y is 3. So one acceptable answer could be, I don't know, 4. As x approaches 4 from the left and the right, it approaches a y value of 3 on both sides. I think you could have also said 2 would be fine, because as x approaches 2 from the left, and 2 from the right, it approaches 3 from both of those. Or you could even say over here, but you'd have to estimate a little bit, at about -8.5, the left and the right approach a y value of 3. Now, of course, you guys sometimes disagree with me, but this individual topic, whether it's a graph or a table, I don't think that these type of questions take a lot of practice. I don't think that these are too difficult. But again, if you don't 100% understand that, then in a week or two, you're going to be back to square one and have to relearn this. We're going to use some of this stuff moving forward. In fact, this is a good way to help us check some of our answers on what we'll be doing tomorrow. But again, we try to give you nice, manageable chunks of what we're doing. So hopefully you feel okay with this. But if you can think of any parts of this that would not be intuitive to you at this point, something you may not remember in a couple weeks, you might jot yourself a quick little note on the top of your page. But that's it for now. Did y'all have any questions on it yet? Anything you'd like me to clear up? All's fresh on your mind? Okay. I think I do have a spot for you to throw that into Google Classroom. I don't plan on grading that for a few days, but I guess it wouldn't hurt you to just go ahead and scan it in and not have to worry about it.